Let's go over our special functions and their graphs, exercise solutions. So determine the parent graph and discuss the shifts of the following functions. So let's look at g of x equals x plus 3 quantity cubed minus 7. This whole quantity being cubed is going to tell us that the parent graph is x cubed. Inside the function is going to be your horizontal shifts. Remember, adding goes left and subtracting goes right. And outside the function is going to be your vertical shifts. Remember, adding goes up and subtracting goes down. So since we're adding 3, that tells us we're going to go left 3 units, and we're subtracting 7 means we're going to go down 7 units. Y equals the square root of x minus 5 plus 6. This square root tells us that the parent graph is the square root function. This minus 5 tells us we're going to go right 5, and this plus 6 means we're going to go up 6 units. S of t equals the absolute value of x minus 4 minus 5. The absolute value signs here tell us the parent graph is going to be the absolute value. This minus 4 means we're going to go right 4, and this minus 5 means we're going to go down 5. R of x equals 1 over x plus 4 minus 7. This being in the denominator tells us that our parent function is going to be 1 over x. This is inside the function, so adding 4 goes left. So we're going to go left 4 units, and this minus 7 outside the function means we're going to go down 7. Let's write the equation that shifts x squared to the right 3 units and down 4 units. So I start by writing the function where I have my x squared, but I have a big set of parentheses inside that square. To go right 3 units is a horizontal shift on the inside of the function, and to go down 4 units is a vertical shift on the outside of the function. Right 3 means I would subtract 3 inside. Down 4 means I would subtract 4 on the outside. Now let's look at this piecewise function, f of x. We have 3 pieces. The piece when x is less than negative 1, that's going to be x squared minus 4. The piece where x is equal to negative 1, then my output's going to be 5. And the piece where my x is bigger than negative 1, then my output's going to be 3x plus 1. So if I want to evaluate f at negative 3, my input is negative 3. Negative 3 is less than negative 1, so I'm going to use this piece. So negative 3 squared minus 4, which will give me 5. Evaluate f at negative 1. Negative 1 is my input. When my input is negative 1, my output is 5, so that is just a function value of 5. And evaluate f at 5, my input is 5. 5 is bigger than negative 1, so I'm going to do 3 times 5 plus 1, or get 16. The next one asks us to graph this. Well, this piece is for all values less than negative 1. This is when x is negative 1, and this is for all values bigger than negative 1. Well, what is the first number that's less than negative 1? You might say negative 2, but there's negative 1.5 in between there. So you might say negative 1.5, but then there would be negative 1 in between there. Negative 1.1 or negative 1.01. There are infinitely many numbers that are less than negative 1, and any number you think is just to the left of negative 1, there's one even closer and even closer and even closer. So in order to account for all values less than negative 1, we're going to start at negative 1, but just not include it. And when we do include negative 1, we'll use this piece to get the ordered pair as we determined here, negative 1, 5. And then here, this is for all values bigger than negative 1. So I'm going to start with negative 1 and just not include it. So I'll make my table of values. For that top piece, I'll plug in negative 1. Negative 1 squared minus 4 gives me negative 3. So I'll start at this ordered pair, negative 1, negative 3, but I won't include it. So I'll give it an open circle. And then I'll plug in other values less than negative 1, like negative 2, and I get 0. So I have this ordered pair, negative 2, 0. Plug in negative 3, and I get 5, and I have the ordered pair, negative 3, 5. For that bottom piece, 3x plus 1, again, I'm going to start at negative 1. 3 times negative 1 plus 1 gives me negative 2, but I'm not going to include it, so I'm going to give it an open circle. And then I can plug in other values like 0 to get 1 and 1 to get 4. And so now I can graph this top piece, which is the piece of the parabola for all values less than negative 1. I'm going to start at negative 1, negative 3, but give it an open circle. then I know from previous that when x is negative 1, I have the ordered pair negative 1 comma 5. Then I'll graph this bottom piece here, 3x plus 1, starting, this is the part of the line for all values bigger than negative 1, so I'm going to start at negative 1, 2 with an open circle and continue. And so when I do that, here's that top piece, starting at negative 1 comma negative 3 with that open circle, and then I have the ordered pair 0 comma negative 2, and this is the part of the parabola stopping and not including at this point negative 1 comma 3. If I start anywhere else, if I were to start at this ordered pair or this ordered pair, I'd be missing infinitely many ordered pairs in between, which is why I need to start at negative 1 and just not include it. Here's that ordered pair negative 1 comma 5. And then this is the bottom piece for all values bigger than negative 1. I start at negative 1 comma negative 2, don't include it, open circle, and then these are the part of the line for the rest of those. And you can see the other ordered pairs we had talked about are on here, like 1 comma 4. That's it for now. See you next time.